Without any further ado, I'm going to get us started with Kelley. Kelley is obviously with KOIN 6 News. She has a BS in atmospheric science and a minor in mathematics, which qualifies her to talk about the weather more than the rest of us. So she's going to tell us more about it. I will warn you, Kelley is a climber. She's a rafter, but she's not a kayaker. Don't hold that against her. She's still a really delightful person to talk to. So without any further ado, Kelley, please tell us about the weather.
Awesome. Thank you, Mark. Appreciate it. Thank you, folks, for letting me lecture you. I've got a lot on the plate here, talking about Pacific Northwest weather, how to forecast, and some about what goes on here at KOIN and what I do on a daily basis. So I'm gonna try and share my screen again. I think this will work. So sharing is paused. Here we go. Are you guys seeing this? Maybe a thumbs up. You are seeing my screen here.
Kelley, we are seeing just a white screen right now.
Sharing is paused. Bring your, let's see if I can get this. Let me stop share and try it again. Okay, we'll do that one.
Yes.
Is that good?
Yes.
Yep, okay. Perfect.
This in full screen. See, it wasn't full screen last time. Let me try this real quick. I'm not quite sure.
We're seeing a great. It's great. What we're seeing is
good?
Perfect. Yeah,
okay,
it's great.
Cool.
Yep.
All right, we'll just go with that. So here we go. Yeah, so I am the morning meteorologist at KOIN 6 News. I work the morning shift. So if you folks are up early enough, we start a real early show at 4:30 in the morning on CBS. So that's channel 6. That means I wake up at 2:30. I curl my hair. I put on a lot of makeup and very tired at that point, but get to work around 3:30 in the morning. I'm cranking out the forecast, checking all these models, looking at the week ahead, and then I prep my graphics, which is very similar to a PowerPoint. Our graphic system online that we use for TV is just like building PowerPoints. So I do that. We get ready for the show at 4:30, and we are live. And then KOIN just launched a new lifestyle show from 7 to 9 in the morning on the Portland CW, which is a different channel. So I have 5 straight hours of live TV, and it's all a lot of fun. I actually really enjoy being in front of a camera and being able to be social while still being scientific in a way too. So today I'm going to talk about a few topics here. First, my background, some of my schooling, and how my career started, and then some of my activities I do outside of the office. Then I'll go into some weather resources for you folks. I figured out that maybe the one thing I could teach you was a little more about weather models and how there are so many free resources for everyday folks who aren't, weather inclined or meteorologists themselves to look at the forecast. You don't have to check your phones or check different websites like Google, typing in Portland weather and getting that forecast. So there are methods and ways to look at models, and there are a lot of resources for you folks. So maybe when you plan your next paddling trip, you can have a little more insight and background to the forecast if there's an upcoming storm, and to just stay prepared. Then we'll jump into a little more Pacific Northwest weather. I think you folks maybe have been around the Pacific Northwest quite a while, and I've seen some interesting seasons, the winter time, some interesting weather here. So I'm sure you have a lot of institutional knowledge of this region. And I've always stayed in the Pacific Northwest myself, but just some more specifics about Portland, maybe that might help you for some paddling trips too down the road. And for specific regions, there are some differences in the weather that we tend to get. Then some fun, we'll talk about some weather folklore. Mark shared some fun things that the old Farmer's Almanac and old myths and proverbs that I'll get into and kind of debunk, which will be a little fun. And then this whole last week, every late October, the National Oceanic and Atmospheric Administration, NOAA, they release their winter outlook. So this year I did my own analysis. I also did one last year too for KOIN, and dived into our current La Nina winter and what that means for Portland, kind of crunch the numbers, and I'll show you some statistics on what we typically see in a La Nina winter, so we can kind of get a better hint about how winter may shape up heading into this winter. So that is pretty interesting. La Nina sounds like a lot of snow, but that's not always the case. So I will jump into that here in a few moments. So my background with paddling is just rafting. So I haven't done much kayaking. I've had a couple friends growing up. I live just off of Lake Washington up in Seattle. I was born and raised in Seattle. So a lot of my time was spent at the lake sunbathing, but every once in a while a friend would pull out a kayak and we just go in the lake. So that's all I know. I don't know anything about if you capsize, how to recover from that. I know some of my friends were a little more into it in college. At UW, there were some classes you could take in the college pool, and they would teach you how to recover and spin and stuff. So never took any of that, but have been able to do several rafting trips around the Pacific Northwest. So most of them are up in Washington. The Titan River, not sure if anybody has ever rafted that or kayaked that, but that's a fun one. They, around springtime, they release the water, so they open up the rivers for rafting and commercial use and recreational use every spring. So that was actually through work. My old station, we always covered the release of that water, of the dam up there. So we got to go on a rafting trip. I think they have class 3s up there mainly. And then the White Salmon River was also another work trip last spring. That was one of my favorite rivers because it's so blue, just like the glacier. It's water straight from Mount Adams. So it was beautiful to go. And that's me and a couple of my coworkers there, the sports anchor, and then a photographer. And it was a lot of fun. You know, the guide is very silly, and it's just a good time on the river. So that was a blast. We went off a 15-foot waterfall, which was very cool. I wasn't too scared. And then this past summer I did the Umpqua River down in Oregon. So not sure how many folks have been that far south or tend to go that way to paddle, but I did see some kayakers and even some interesting kayaks. They weren't quite paddle boards, but they were sitting, and it kind of looked like a kayak without the cabin. So that was interesting to see. And there were some class 3s and 4s on that one too. So rafting is fun. I tend to go maybe once every 2 years or so, and hope to get to more rivers, maybe the Deschutes in upcoming summers. So it's cool that you folks do this, you know, maybe on a weekly basis or a seasonal basis, and get out to all the beautiful rivers here in Oregon. Let's see if I can slide the next one. So a lot of my outdoor resume is with climbing. So it started out with mountaineering. In college, my junior year at UW, I summited Mount Rainier. That was the first mountain I ever did. And I was using very thin snow boots. I had no idea what I was doing, but I had a group of friends who were mountaineers. So it was very fortunate for me to find a crew to teach me about the hobby instead of having to pay for a guide. I know a lot of folks who pay maybe up to $1,000 for a guided trip up Mount Rainier. So I was young, 21 years old in the summertime, went up Mount Rainier, and it was a blast. I came back and did not use sunscreen on my face. And even though it was cloudy and overcast the entire time, I had a major burn across my face. It was a ski goggle tan. It took 2 nights, 3 days to get up there. And I was taking summer classes at that point. So imagine me completely battered, could not walk without limping, so tired from the trip, and half of my face was beet red and burnt. So that was a pretty interesting moment for me to just show up to class like that. But that kind of kicked off my outdoor activities, especially with mountaineering. I then made a goal to summit all of the volcanoes in Washington. So that includes Mount Baker, Mount St. Helens, Glacier Peak, and there's one more, Mount Adams. So I finally finished that in 2017, and now I'm working through Oregon's volcanoes. There's about 8. So I've done Mount Hood and South Sister. I have to do the other sisters, and Mount Jefferson will be pretty tough. Not sure if there's any mountaineers in the group, but you know how it is type B fun. You don't really enjoy it until 2 weeks later after you've hit the summit and remember how good of a time it was, even through all the struggles. These days, I spend a lot of my time rock climbing, so not so much mountaineering. I go out to Smith Rock quite a bit. This weekend, I'm actually going out there to climb. Once again, there's a good weekend of weather and temperatures won't be too cold out there. So it's nice to be able to forecast too and plan out my adventures. My friends are always looking to me, you know, ahead of time, maybe 6 to 7 days out. What does the weekend look like? Can we plan something fun? And east side rock climbing areas are always drier. I learned how to climb in the Tri-Cities and love the area of Vantage and Leavenworth. And there's a couple of areas that are in the desert for climbing. So when I moved to Portland, it was a much different climbing scene. Everything is very mossy, even out in the gorge. You have all these craggy peaks and towers that are climbable. I've climbed Beacon Rock 3 times to the top, and it's all very mossy. So a very different type of climbing here in Portland compared to maybe the Tri-Cities and Eastern Washington. So it's really cool to explore the region, and I'm sure you folks notice these things too while you are paddling across different rivers and maybe across the ocean. So my background, I was born and raised in Seattle. I attended the University of Washington in Seattle, graduated in 2014. So if you do the math, I'm 28 years old. I study the atmospheric sciences, which is just the study of the atmosphere, not specifically forecasting. I had to choose that track within my studies. So a lot of it was just your base physics and dynamics and thermodynamics. And I did a focus in climate science and meteorology. And a lot of my classmates either went to grad school to study more atmospheric sciences, or they became officers in the Air Force or some of the military branches. So I was the only one to actually go on TV and go the broadcasting route. Our department really wasn't focused on that at all. So it was kind of a shock to my department when I decided to put a reel out. So you have to audition at news stations to get on TV. And my studies didn't involve any communications. It was all science, science heavy. So I learned a lot about the TV industry through my internship at Como News throughout my senior year in college. So that's a big station up in Seattle. It's Channel 4. And I spent about 6 months to a year there just practicing on the green screen, set up an audition tape that you put on YouTube, and then all the news directors take a look at that video and check you out. Can you speak in front of a camera? Can you hold composure while you're speaking in front of people? And can you tell the science story, the weather story? So I got a job in the Tri-Cities at Keeper Action News, and it was a really fun 3 years. I was promoted to the morning full-time weather spot after a year and a half. And then after 3 years in the Tri-Cities, I got this job here in Portland, and I've been here for about 2.5 years now. So my career is only about 5.5 years long so far. And it was very rewarding to jump to a big city, because typically you'll start in very small TV markets. You work your way up to a medium-sized market or medium-sized city. And then you get to a large city like Portland. So I knew I wanted to stay in the Pacific Northwest, and maybe would have jumped to Spokane, which is a medium-sized market, and then hopefully back to Seattle. But landing in Portland was just a fantastic goal that I achieved. So I'm very happy to be here. It's very similar to Seattle. I have family up there. My brother and my parents are up there, my 2 brothers. So it's a nice place to be, not too far away. And I'm loving living in Oregon, and I have a couple of relatives down here in Portland too. So pretty familiar with the area and the Pacific Northwest in general, and just very happy to be here in the region, still able to climb and mountaineer and hopefully kayak in the near future. So wanted to jump into weather here. Just first off, a look at Hurricane Zeta. It's currently out there now. So wanted to show you guys that on the satellites. It's our latest hurricane. It made landfall today. It's a Category 2, which means its maximum sustained winds were measured at 110 miles per hour. And what's so interesting about this year is that we've had a record number of tropical systems in the Atlantic Basin and the Gulf of Mexico. This has never happened before. So, and also for Louisiana, we've also broken records too. There have been, I believe, 5 named storms this year, which beats the record of 4. So just by one named storm, whether that's a tropical storm or a hurricane. But Louisiana just continues to be battered across the South Coast. And it's just devastating to hear. I can't even fathom a storm surge, that just floods the land, and then rainfall that just floods your house, and then not having power for 3 to 5 days. Imagine that, and trying to survive in that situation. So this is currently going on. Its trajectory is towards the northeast. It'll likely hit the Mississippi coast, and already doing so right now. We had to break into the Greek alphabet for names. There's usually about 22 names, I believe, for every hurricane season. They retire names when they become deadly. And this year we ran out of those set of names for 2020 and moved into the Greek alphabet. So Zeta, I think, is number 6. Next would be Eta. And Zeta is now the 11th named storm, 6th hurricane this year to make landfall. And those are both new records. So it's just been an incredibly active hurricane season. It's been fun to track. And here in the Pacific Northwest, don't really focus much on hurricanes in my forecast. They're fun to mention, but I'm not really forecasting these massive systems like other news stations along the Gulf would be doing so. But they're still very cool to see. So here we go into weather resources. I wanted to share some of my favorite models that you folks can also use for maybe future trips if you wanted to check out any weather systems that are rolling in. I like the quote, "By failing to prepare, you are preparing to fail." And apparently that was said by Benjamin Franklin. So I changed it to my own version. By failing to forecast, you are forecast to fail. So just a little tip there for you folks as you head into your next adventures on the water and get to some paddling. Hopefully you can use some of these resources and some models that can help you forecast. So one of the first things that I look at is the satellite. It's very important. It's the current look from above. Satellites are in space, I'm sure you guys all know, but this is our brand new GOES 17 a satellite that looks at the Western US. I think it's about maybe 6 months to a year old now. So this is a resource that you can look at to watch some incredible systems. This one was from the late winter last year, but this is just a low pressure system. And we see these quite often. And they roll into the Pacific Northwest. These are our weather makers. They have a cold front and a warm front, sometimes an occluded front, and a very low center of pressure. So these things kind of roll like bowling balls right into our region and bring weather into the Pacific Northwest. And we see a lot of influence from the ocean. So these systems, compared to some of these weather systems that are in the eastern US, we have the trade winds and the westerlies. So a lot of these systems roll from west to east, but having the ocean there kind of ramps up some of these systems too. And then as they hop over the Rockies to the east side, they also gain some strength. So it's pretty interesting when you are in the springtime and you see one of these systems coming into Oregon, and then a week later, the same system will continue to move and traverse the US. It'll hop the Rockies and it'll strengthen, and then you'll see some deadly tornadoes forming from that same system across the Midwest. So it's kind of hard to forecast in my area or this area because we have such mild weather. We really don't have much to worry about aside from volcanoes. You know, we sometimes get tornadoes, we'll get some heavy rain and flooding, but it's really not as impactful as some other regions across the US. And I do believe that Washington and Oregon, and also California, I guess, have the best weather in the entire US in terms of just comfortability. I know California is changing because they are drying up real quickly and forest fires are becoming a major issue. But still, in general, I think we have some great weather here that's very livable compared to other regions of the US. So just a little touch on low pressure systems. So that satellite imagery is exactly this. So you have that low pressure center. The blue front is a cold front. The red line is a warm front. They're always swirling from counterclockwise. And you get a nice rain band that forms both on the warm and cold front, but typically it's the cold front and those rain bands that affect our region and swing into the Pacific Northwest and bring us our rain. Typically when these systems roll into, they sometimes bring very gusty winds. And when these low pressure systems grow or drop in pressure, they can produce some windstorms. And we haven't seen too many windstorms where wind gusts or sustained winds have been around 50 or 60 miles per hour. And from last year's research, we are overdue for a major windstorm that may come in the next 1 to 5 years. So this winter time, when we see our most stormy and rainy periods, there is a chance that we get a big windstorm this year. So we will continue to watch as we head into the winter time. We're now entering the most active season for us, where we get the most rain from October through about May. And we can get windstorms and even some snow. So these will be systems that if you plan to look at weather models, you can see, I'll show you here in a second, but you can see the low pressure center and you kind of map out these fronts. The structures of these all look very similar. So it's really cool to see one popping up here on the satellite. Then you go check the model and look out in the future and you can see these systems rolling in too. So not sure if anybody's ever looked at weather models. They are mostly free online. And this one here, this picture is provided by UW. So at one point, the UW weather department or the college was commissioned by the Gorge. There's lots of wind farms out in the Gorge. So they developed this very high resolution model that helps with winds so that all those wind farms can forecast energy out in the Gorge. So I love the UW model. It's called the WRF or the WRF because it's very high resolution, specific to the Pacific Northwest. It's a great model. It's free. If you learn how to navigate it online, that can be a little difficult, but it's just a fantastic resource to look at these models. So let's see if I can draw on this slide here. We'll do the red pen. So this is a weather system. You can see the low right there, and you can see the cold front. This is a system that was from a while ago, but that would be the cold front. So these structures are very similar with every low system, and all forecasters start to get gray hairs when we see these systems rolling in come the winter time, because that provides a chance for snow even in Portland. So we have a tough job to relay the forecast in a manner that doesn't create too much buzz or too much, I guess you could say, hype, because a lot of schools and businesses rely on our forecast. And if we, over forecast snow, people really freak out. And if we under forecast snow, then folks are unprepared, and that could mean some hazards for people. So it's very tough come the winter time to be very open and communicative with the weather forecast. But these systems will roll across the Pacific Northwest, and you can really see the timing on when the rain will arrive. There are a number of weather models that may take some time to get used to, but they're all very helpful. Also, these are weather models. They're produced by initial conditions that are pumped into very complex equations. They go out maybe 5 to 6 days. And after about 3, the forecast tends to be a little less accurate. The skill drops severely. So with snow, the forecast is only very accurate 1 to 2 days out. For rain, it's about 3 to 4. You can see larger scale systems further out, but to get that refined forecast for a smaller area in Portland versus across Washington, Oregon, and California, you have to check on models a little closer in time. So I wanted to show you guys a couple of models here. So this one is the UW model. It's a free site. And I think after this, I'll maybe send an email to Mark or share it in the conversation. You guys can have these resources for later. But this is the site. It was made by computer nerds who, weren't really trying to make it look pretty, but it's still navigatable. And you can see here, I'll show you, we are expecting some rain on Friday. And if I pull up one model, so this is a look at Oregon. It's a high resolution 4-kilometer model. So it's looking at just Oregon. It's really zoomed into Oregon versus that last model, which was across the West Coast. And this is looking at just rain. And you can see the front sliding in here come Friday afternoon. There it is. And it dissipates. So I use these models often to interpret the rain and the forecast for the end of the week. I'll show you a little bit wider, a little more zoomed out. Talking might be better. There's so many variables too, and so many levels of the atmosphere that you can look at. And but if I show you just a few models and a few variables, you may be able to see better. That's actually not what I want. Okay. But these are fantastic resources to look at precipitation. You can look at temperature. I really like looking at weather fronts that move in. So I'll find you we'll just go back to this one. And you can see our current system that we'll be tracking. So I will grab this guy. Okay. So right now we have a ridge of high pressure. Oh, I can't draw anymore. So it's kind of a blocking pattern. We don't really see weather systems come in when high pressure is in place. High pressure typically it coincides with sunny, dry, calm weather. And you can see the system developing off the Pacific. It's right now just above Vancouver Island, and then it rolls into the Pacific Northwest. It swings down and the cold front moves on in. This one is a very weak system, so the cold front is not as prominent. But these are lows that you can watch, and we're mapping pressure here, and all those colors are rain. So it's just really fun to see these low pressure centers. I just see them as bowling balls that roll across the state. So this is a very wide view, but you can also, zoom in like I just showed you, and take a look at the rain and the front specifically. You can go by 1 hour, you can go by 3-hour rain totals. So if you're interested, you can look at all the variables and play around with this. Here's again the 4-kilometer view, and the time bar is up above, and you can see the rain. Again, we're expecting it around the afternoon on Friday. So there it comes approaching the coast. So that is, you can see the metrics down below. Those are centi-inches, so they're hundredths of an inch. And yeah, you can see the timing. And the thing about models is they all have their strengths and weaknesses. So the WRF, I think, does a very accurate job with forecasting temperatures and snow. And it does so because it really has that zoomed in view. It gets down to 1.3 kilometers resolution. So that's about the size of the valley, the northwest corner of Oregon. So you can really see when a system rolls in and winds from the south are just above freezing and they're ramping up, and it's going to be a little too warm to actually see snow hit the surface in Portland. This model is fantastic with doing so. Again, here's that front and the rain that's expected to roll in. So by 9 a.m. tomorrow, likely we'll see some light showers here in Portland. I'll show you winds, which may be most helpful if you guys are paddling around. Get to the 1.3 kilometer view. And because the UW was commissioned for wind farms, they have very high resolution models for more areas than the other variables like rain and pressure. So you can see in the gorge or the Oregon coast or the Oregon eastern slopes, I like looking at the gorge on the west end because it gives you a good look at Portland. So these are all wind bars. And you can see as a system comes in, how the winds change. And of course, you may need to look at more, learn or know a little bit more about weather, but in terms of like how winds revolve around the system. But mainly from the south, you'll see them ramping up, and you can see come Friday morning. So this is ahead of the front. These winds are coming from the south. They get a little more gusty here in the valley. And these are all cues that are just pinging in my head like, oh, wow, we're going to see these things. But if you are paddling around some of the rivers around here, this model could come in handy to see some winds at a higher resolution. If you wanted to forecast your own adventure, over a weekend, if you're heading out to some area and a river out there. So that's my favorite model in a very quick sense, just looking at that. This other site is also one I like. It's a little more intuitive to use. It's called Wind Finder. And I'm sure you guys maybe have some of your own phone apps that you use for high resolution wind. This is using the American model, but I like it because you can really choose, you can see the winds, and those bars are really easy to see. So winds right now are coming from the north, and it's just a good view. You can zoom out and see Oregon, and to me, it's just incredibly intuitive. There's layers on the sides that will show you, let's see, I think you want forecast, stations. But yeah, you can see it on a map, or you can see it also in a graph form, which I really liked. So you just pull up let me find it real quick. So there's that too. Look at winds and move it out in time. So like tomorrow, see the weather system, and you can go by hour or by 3 hour marks. So this was a little easier to use. It's using a different weather model too. It's not the UW model. But there are different weather models that are out there. These are all websites that are very easy to navigate if you wanted to forecast for your own adventures. So that's just a brief look at some of those models. Again, there are global models that we have. Some folks may have heard of the GFS. That's the American model. And every time we talk about it on TV, it's like our major American model. There's also the European model, which goes by the Euro, or the ECMWF. It's an acronym that's pretty long, but that model is always competing with the American model. So those are two big ones we use when we have snow events. What is the Euro saying? What is the GFS saying? And they often will give different results for the forecast. If we're expecting snow on Friday, maybe the European model is saying 2 inches and the GFS is saying 0. So there's sometimes an issue with deciding which one you want to follow and which one you want to share on TV. It gets very complicated and honestly a little stressful when two models don't line up with the very impactful forecast on the way. But the GFS does very well. It does better in the heart of a season, like transitional weather from summer to fall or fall to winter. It tends to miss some systems and the timing on cold fronts. The Euro does a little better than that. And then my favorite model, the WRF, does very well as well. So that's a good one.
Hey, Kelley, we have a question.
Yeah.
How do your resources compare with NOAA?
Yeah, so NOAA has a fantastic site. If you want to know weather from NOAA, it's the National Weather Service. So NOAA is the overarching organization. The National Weather Service is the weather-focused one. Yeah, they have a team of meteorologists in every large city, or most large cities. I think we have 3 National Weather Service centers here in Oregon. There's one in Medford, Pendleton, and Portland. Seattle has Pendleton, Oregon is for part of Washington, Spokane, and Seattle. So there's a number for each state, and they all have a team of meteorologists that are also interpreting the same models and then providing the forecast. So if you go to the National Weather Service, I can actually look it up for you guys. NWS Portland. So this is our forecast page. I use it as a resource too. I'm actually friends with a lot of the meteorologists that are there. They're a fantastic resource to call for stats. You can also call them and ask them what the forecast is. It's their job just to be a service to the public. So you can look at their map. It's very clickable. The one thing I don't like about this site is sometimes it's very hard to navigate and you can get lost in it looking at all of their products. They also give off their own hour weatherly forecasts. As you can see, it's a side tab that you may miss, but they have these types of forecasts as well. That'll give the temperature reading throughout the mornings, the winds. So they actually do a pretty good job. They tend to go a little more conservative on temperatures. Like if, especially in the summertime, they never really wanted to forecast extreme heat or temperatures in the 90s. They would always say 89 instead of 91 degrees for the forecast the next day. That's what I've noticed, but they're doing the best they can. I think they're also a great resource. So I would suggest using their products and their website along with KOIN as well, and me hopefully. But yeah, they do produce good stuff, and I have nothing but good things to say about what they do. And also, I don't know if you folks are on Twitter, but I have found that Twitter is the easiest way to learn about inclement weather on the way, especially with wintertime. Not only am I tweeting out weather information, but so does the National Weather Service. And it's just the quickest way, I think, to see an upcoming system. If we're going to get snow, it's the quickest way to get real information from a trusted resource in terms of weather. So I would suggest, getting a Twitter. It's just an app on your phone and just following these folks, and you'll get the forecast daily. We're always sharing things. Portland and the National Weather Service in Portland does a very good job with sharing information as well. So pretty cool resource there too. But this is their site. You see the forecast. You can click in and read it. They also have a radar that you can see. But in terms of their accuracy, they do a fairly good job with temperatures. And so do we at KOIN. We try and hit at least 1 to 3 degrees, away from the high or near the high or low temperatures. So yeah, I suggest using them as well. So those are my favorite models, Windfinder or a website like that, but I do like Windfinder because it's pretty easy to navigate. And I really encourage you folks to look at weather systems yourselves before you hit the waters. I know winds can affect how choppy water can be, and possibly, provide a good or bad day paddling. So it could be fun to start forecasting yourselves first by looking at some of these sites, and hopefully it wasn't too confusing. It may take a lot of time or a little bit of practice to navigate some of those websites, but all the resources are out there. And it's pretty fun to forecast yourselves. Let's see. Okay, so you may also just read observations. The National Weather Service, a lot of folks give out observations at the current time of what the winds are. So these are just how to read those wind bars. Everything is in knots, so you'll have to convert to miles per hour. But typically they'll look like this, and not every wind bar will have all this information on it. You'll typically see sea level pressure. Oops, let's go back here. You'll typically see sea level pressure on it. You'll see the wind speed. You'll see temperature and dew point. Sometimes you'll see a weather symbol. You'll see cloud cover. But it's nice to know the winds, especially if you're in the gorge, because that is an area where winds can really ramp up, and they tend to, Hood River is a great area for kite surfing, if you've noticed. So, reading observations like that, if you're heading out to Hood River or around the Columbia to paddle, some of these winds and observations may be helpful. So just kind of reading wind bars too. Everything's in knots. And you can see calm will have no bars at all. 5 knots, 10 knots is double the size of the first bar. Then it transitions to a second bar when it hits 15. 50 knots is a triangle. So I pulled up this from a couple days ago. This is out of PDX, which is the Portland airport. Winds are coming from the east. So also what differs from a marine biologist or an oceanographer versus a meteorologist is that we do winds completely different. It's kind of, I think it's more intuitive how meteorologists read wind bars, but we always, the winds will be coming from the way they're pointing. So this wind bar is pointing from the east, winds are from the east. It would be completely the opposite if you were an oceanographer. And I went sailing with my friends last summer and had to tack the sails, which is when you flip the sails because you're changing directions. And I was getting so frustrated because I didn't understand the process. And it was all because their anemometer on top of the sail was relative to an oceanographer. It was completely backwards. So as soon as I figured that out, I was like, you guys didn't tell me that it was, the opposite way. I was doing everything backwards. So keep that in mind when you're reading weather and winds. It'll be winds are coming from. So if you look at KMMV or KUAO, which I believe is, I don't actually know what that is. KSLE is Salem down here. So winds are mainly from you could say the northeast, mainly from the north, a slight east direction in there too. KKLS, which is, I want to say maybe Scappoose, maybe, it's up in Clark County. Then there's Astoria as well, but winds are from the north at about 5 knots. Winds are at Astoria, they're from the east northeast at 10 knots. So that's how you would read that. And the conversion is, let's see if we can get to it. 1 knot equals 1.2 miles per hour. So these will be helpful if you are looking at observations, if you ever look at a marine map and see these, just how to read these. And you can find these observations on the National Weather Service and NOAA as well. Okay, that's enough about forecasting. Hopefully that wasn't too confusing. And again, I'll share some of these links, but I very much encourage you folks to just kind of, if you have free time, just to navigate through some of these websites and look at all the variables that you can see, and keep an eye on pressure systems that roll into the Pacific Northwest, because we'll get more and more of them as we head our way into our winter time. So this was fun. The Old Farmer's Almanac is full of entertaining articles. And the first weather myth I wanted to talk about was the woolly bear caterpillar. I've actually heard about this a while ago, and I haven't seen one of these caterpillars in the Pacific Northwest. They say they're all around the US, but they're very furry and they all have an orange stripe in the middle of it. So the myth says that the amount of black fuzz or the red fuzz varies proportionately to the severity of the upcoming winter. The more black, the more severe, and the more red, the more mild. So this is completely false, because folks tend to think that what the caterpillars ate could maybe speak to the vegetation and the weather during fall time, and what that may bring for the winter time. But basically the red section is more of an indicator of just how the foliage was during fall versus an indicator of how winter will be. So these guys also molt and shed their fur too, and every time they do, they'll lose a little bit of their black. And so it's just a common thing that some folks will think about. If you see a caterpillar and there is a lot of red on it, then it'll be a mild winter. I can't wait to see one of these in person. I hope I do, but it is completely false. It's just a caterpillar that eats a lot of vegetation, and its age and what it ate and how old it is affects the coloring on its fur, and pokey, colorful fur than the actual diagnosis of wintertime. So I thought that was cute. I really want to see one of those because they're just so furry. The next one is red sky at night, sailors delight. Red sky in the morning, sailors take warning. So apparently, if you see a very red sunset in the evening, that's a good thing. It means fair weather on the way. Typically, sailors on the water would have nothing to worry about the next morning. But if you saw a red sky in the morning, then that means there's a system on the way. And I want to say this is half true, because when you look at large scale winds, we have the westerlies that flow right through our latitude. And we tend to see weather systems moving from west to east. So they move inland across the valley, then they go across the US to the east sides of the US. So when you see, a red sunset, there's no weather out there. It's pretty fair weather, and that'll likely linger into the morning time. So that's half true. It's a good sign, probably in a fair weather pattern. But what's interesting, and this is a photo from our weather cameras out in Lincoln City from October 5th. We saw warm temperatures, warmer than normal temperatures. It was the mid 70s out towards the coast, and we were dry. So red sunset, beautiful weather. Sometimes that can be true, but in the morning time, I was a little confused. I don't really know what they mean by a red sunset, because this was taken the next morning, and there's a little bit of red in there, still some calm weather. And even this morning, the sunset looked like this as well. But I made this a little while ago. So a red sunrise in the morning doesn't always mean bad weather. I think you can sometimes see the sunlight refracting off of cloud tops that are higher, and some of those clouds may be a little more stormy. I'll show you this graphic. So the structure of a cold front tends to produce, when the cold front works in, it's very dense air, and it comes in very close to the surface. So when that cold air starts to flow in, all the warm air starts to rise, and that's convection. That's the area that clouds start to form. You get storm clouds there. And sometimes you'll maybe see the tops of those be a little more red. So possibly that can mean some weather is on the way, but I don't think there will ever be a point where you're paddling and you won't be off the water in time for a storm system to come in, especially if you're going off of a red sunset and it's just a beautiful weather period as well. But sometimes the cloud tops can be very wispy. So if there is a more convective system brewing, maybe this is a thunderstorm. This is a cumulonimbus storm. So a thunder cell, the very tops of those cells can extend out further than the cold front. So those wispy high clouds will reach you first. And I have been backcountry skiing on, it was Mount Baker, a couple of spring times ago, and that's a very convective season. We tend to see thunderstorms in the spring, and I saw the push of some very wispy high clouds, and then it was a beautiful sunny day first. So the high clouds came. I was a little bit nervous, and also knew that we were going to get into some active weather that afternoon while we were skinning and skiing around Mount Baker. And then the clouds got real puffy and we were hit by thunderstorms. So sometimes it can be true that you see these high, thin clouds first. If you start to see the blue skies go away and higher white clouds, very wispy, rolling in, sometimes that can be the leading edge of a cold front. So it's pretty hard to detect. And we'll just take some more practice and, noticing these things when they do come in. But I think that is pretty interesting and makes that myth like half true. The next one is a clear moon, frost soon. So that means if there are no clouds out, it's going to cool down, and that may bring some frost in the morning. So yeah, sometimes that can happen, mostly true. Heat escapes at night. We lose our insulation. And sometimes frost can develop, especially if we're in the late fall, winter time, kind of like now. But also fog can also develop too, which may inhibit frost. So because there's a clear moon, more likely it'll get cold, less likely that frost will always develop. But that was another interesting one as well. Ring around the moon, rain real soon. So another half true one. Like I was talking about, all those high clouds that are ahead of a front are made of ice. They're not water or dust droplets. They're way higher in the atmosphere where it's chilly, and ice is the typical structure of the cloud. And you can see those halos around the moon. I've seen them a few times in my life, and it's really cool to see because you can't really see the cloud itself, but just there's this layer of cirrus clouds that are very high up there, and they're all made of ice crystals that are hexagonal, and that's just the way that ice forms, and the moon refracts off of it, and you get a halo. So sometimes that could mean that it is ahead of a weather system, but I think you should just take all of these with a grain of salt and just know that when you do see a halo, that there are clouds up above, and they're very high cirrus clouds, and they're all made of ice, which is why that halo forms. So it's a pretty cool phenomenon that happens here. We can sometimes get it in the wintertime when we get real cold, and also in the summertime too. So that one is half true. A little bit about weather specific to Portland. Typically our winters are mild and rainy. Sometimes we do get snow. It's become a little more rare. We do get some snow events. We've had several over the last maybe 4 decades that gave us more than 8 inches of snow in Portland, but it has been a little more rare. But how we forecast is the coast range itself. The Willamette Valley is big because that's where a lot of folks live. It's the most populated. We forecast for the Gorge and then the Cascades as well. So through springtime, general warming, it gets a little more active. So there's more thunderstorms at that point. Summertime is pretty dry. We see about a 1/2 inch of rain total, both in July and August. So very dry. It seems like every 4th of July, the tap just turns off and we don't see much rain at all. Fall starts to cool very quickly, and we can see a lot of fog in October and November. Rain can also be pretty heavy, and we even see tornadoes. There's been, over the last a few decades, there have been more reports of tornadoes just because more folks have had cell phones to take pictures of damage and pictures of some of those funnel clouds that hit the coast and then progress into the valley. So it's not like we are increasing the amount of tornadoes. It's just the observations of these are increasing because we're growing in population and smartphones are more prevalent in our everyday lives. So that was pretty interesting to see. We can also get some tornadoes in the springtime as well. A major wintertime weather, I guess, situation is these inversions. We kind of saw one this morning, and that's when you get a lot of trapped fog that kind of sits in the valley. It sticks around sometimes even into the afternoon or all day. I hate when these set up because it makes the forecast real tough, and sometimes we can bust our forecast. I'll forecast in the wintertime a high of 50, and these inversions set up with fog that is just trapped at the surface, and we don't break out of the low 40s. That happens quite often in the wintertime. So that's when you have very dense cold air that sits in the valley, and you have warm air above, and it just traps. It acts as like a capping layer. So it can be sunny, maybe at 5,000 feet, but we're just sucked in with clouds here in the valley. And we kind of saw that this morning. So another thing that meteorologists look at are Skew-T charts, which are actual observations. These are balloons that are launched, and they track the temperature profile and just the profile of the atmosphere, the winds, pressure, dew point, all the way up. It gives a good reading of what the atmosphere is doing. So the blue line is dew point and the red line is temperature. And in this case, everything's in Celsius, and the height, the y-axis is pressure. So pressure decreases with height. So you can see that we're completely saturated here near the surface, which is that 1,000 layer line right there, which just shows that as there's a huge thick cloud layer. It's very saturated. The dew point and the temperature are at the same temperature, which means that clouds have formed, and above it you see warmer air trapping that colder air below. These are a little bit more complex to analyze, but this is a very standard signature of a capping inversion here as you look up in the atmosphere with that temperature profile. So these are fun to look at. They also have forecasts for these too, which we also use in the wintertime to kind of see temperatures. As soon as the surface temperature is below 0, that means it's freezing, 32 degrees, and you can see warmer layers. It's a good way to forecast freezing rain, which we tend to see a lot in the gorge and even sometimes in Portland. So pretty complex. Chilly east winds are also something that you may have noticed over the weekend. We saw extremely gusty winds from the east. The Columbia River Gorge acts as a channel that just opens straight into East Portland. And when there's a large temperature or pressure gradient that tends to increase winds, that's what forms winds. And as you can see, between the 0 Celsius temperature and the -9 Celsius temperature, those are massive pools of air. And one is much colder. The purple there is much colder. So this was a forecast into Sunday showing this Arctic air mass dropping into Eastern Oregon, creating this major temperature gradient, and that really fueled winds. And we were forecasting a chilly east wind, all that cold air, that -9 degrees Celsius air would kind of work its way into Portland. And it did. You can see that here. I pulled last Sunday's observations right around 3 to 6 p.m. We saw very chilly high temperatures, only in the 40s. And we saw winds were coming from the east out of the gorge, and they were gusting up to about 25 to 30 miles per hour. So these setups happen quite often in the winter time. And when we see some weather systems or low pressure system rolling in as well, it can create these very icy situations where there's ice in the gorge. So this is a fun thing to track. And I love when these setups happen because this is just a perfect signature of a chilly east wind. And we got that exactly on Sunday. The forecast did very well with the timing of these winds and how chilly it would be, and even how strong the gusts would get. So it's just a good example of how well forecasting has come from the 1980s and what we can forecast at this point. As we head into October and May, we see the rainiest of the seasons here. 90% of our rainfall falls between October and May here in Portland. We also tend to see coastal waterspouts. So these can be some scarier funnel clouds. They mainly stay off the coast, and they tend to die as they make their way inland, but sometimes they can form into tornadoes, like the Manzanita tornado. That was the deadly one. I believe it was, I forget the date of it, but it was one of the most deadly tornadoes that we've seen here in the Pacific Northwest, in Oregon at least. And that was a waterspout that formed into I think it was an EF 2 or 3 tornado. And it did kill a couple people. And so we're actually in waterspout season. If you're off on the coast and we get a weather system rolling in, there's a fairly good chance you see some of these waterspouts developing. Snow is definitely harder to get in Portland these days. We have to really pair cold air with the rain, and all last season, we didn't get much snow because we just saw too many warm tongues of air up the valley into Portland, kind of warming things up when that rain arrived. So we didn't actually get snow. It's almost like there's a setup where chilly east winds kind of push its way into Portland, and then we get a weather system, the precipitation comes, it'll fall as snow, but those two just never matched up last year. And hopefully this year we do see some snow events. I'm a big fan of it. So I would love to see hopefully some weather systems that do bring us some snow and some cold enough temperatures to get that snow. But yeah, last year we only saw half an inch of snow in Portland, which was about 4 inches below the normal amount that we typically see in Portland. And it was just because we never got cold enough to see snow form when we saw our weather systems here rolling on in. The gorge is very prone to icing. So they get those cold east winds. They also get a bit of a temperature inversion where maybe the surface is at freezing, the layer above the surface is a little warmer than normal, and then the layer above that is colder than normal. So when a droplet of water falls through that, it becomes super cooled, and then it can ice on contact when it gets back to that freezing layer at the surface. So that's a common thing in the gorge here, where I-84 can get shut down. There can be semis lined up for hours as they're clearing out some accidents and crashes out there. Summertime thunderstorms are pretty common too. This was one from Ridgefield that we saw in June or July 2 summers ago. It was a pretty active day. So we tend to get a lot of lightning and thunderstorms heading into our transitional seasons. So from winter to spring, and then from fall to winter. A little more on tornadoes. Our average annual tornadoes, both in Washington and Oregon, are, we get about 3. Which compared to Texas, they see about 155, and they get way stronger tornadoes too. We tend to see EF0 to EF2 category strength tornadoes, where winds could hit up to about 100 miles per hour, but only for a brief moment. The National Weather Service has a team of meteorologists that always go out when these situations occur, and they'll assess damage. So how they track the strength of a tornado is going to a damaged site afterwards, and they'll take a look at the debris, and then they'll assess and decide how strong that tornado was. It's pretty interesting how they do that. I don't know too much more about the actual protocol, but it's interesting how they assess the damage, and that's how they put a mark on the strength of that tornado. So we are entering, there's 2 peaks. It's a bimodal distribution of tornadoes in the springtime and the fall time. We tend to see the most tornadoes here in the Pacific Northwest. And you can see that lower picture was from last winter, I believe. We saw an ominous cloud forming in a funnel cloud. That wouldn't technically be a tornado. It has to touch the ground, so that would just be a funnel cloud, but it can still cause quite a bit of damage as that very isolated small cell rolls through. Okay, this is the last thing I wanted to discuss. I spent maybe about a week or so just crunching numbers and giving a winter outlook for this winter. You tend to, there's no way to know how much snow you'll see in a month this far ahead of time, like at all. So even forecasters who say they know the amount of snow 5 days ahead of time are full of crap. So don't listen to them. And make sure to, if we do see a weather system coming in this winter, to really pay attention 1 to 2 days out. That's when we'll know the areas that'll see the most impact. So just in general, this was my analysis based off of previous La Nina winters and some of the data that we've been seeing. So typically a La Nina will bring wetter and cooler weather into the Pacific Northwest. So that tends to coincide with more snow in the Cascades, and even some snowfall here in Portland. Our last La Nina year or winter was back in 17 and 18. And I think that was just before I got here. I got to Portland in the summer of 2018. So 7.6 inches in a La Nina year. We see a pretty rainy wintertime too. So there tends to be, the jet stream sets up where it will allow for more weather systems to follow that storm track and kind of drop right into our region, which is why we see more rain. So we tend to be more stormy in our La Nina winters too, which gives us those wetter conditions and sometimes a little bit more snow. Good news for Cascade snowpack though. I really do think we'll see a pretty good ski season, or just a lot of snowpack for the Cascades, which is good for our water supply as well. So the Climate Prediction Center is another branch of NOAA, and they focus on climate, and they also give outlooks, which do pretty well. But these are the outlooks for December, January, and February, which is the meteorological winter time. The astronomical winter time starts around December 21st, but the month of December is the first start of winter for meteorologists. And this is showing that over those 3 months, there is a higher probability for below normal temperatures and better probability for more precipitation, probability of above normal precipitation. So it does look a little bit wetter and cooler. Now, this doesn't mean that we won't see dry spells or even some record heat. It's just averages over the entire 3-month span. So there could be a section of January where we are extremely dry or even warmer than normal, maybe in December. But just in general, over the 3 months, the outlook is showing a better chance for higher than normal precipitation and above normal temperatures. So tracking La Nina, if you guys know much about ENSO, it's really just the oscillation of warmer and cooler water across the Pacific. So you can see in this map here, the blue is the cold anomaly. So sea surface temperatures are colder than normal. You can see this big pool of cold water across the tropical equator, and it's pushing its way towards South America. So this is a signature of La Nina. So this year we are going to be in a La Nina that is moderate in strength. So what I did was I tracked other La Nina years and put those weather observations against each other just to see what we would get. So here is a look. Hopefully that's not too hard to see, but you can see all the dots in blue are La Nina winters. And these are total snowfall at Portland. The official observation site in Portland is at the airport, PDX. So as you can see, there were some winters in 2017. That was a La Nina winter that gave us 11.2 inches of snow. The 17-18 winter time gave us 7.6. You will notice how over the last maybe 20 or so years, there were 2 major snowstorms. That was the 2017 winter and the 2009 winter when we saw 24.2 inches of snow in Portland. The red dots are all El Nino winters, which tend to give us, warmer and drier weather across the Pacific Northwest come wintertime. And all the black dots are when those ocean waters are neutral. So we're neither in a El Nino or La Nina year. And those can just be wild card years. And that is what we saw last year. I had forecast a very snowy winter last year, and we saw a half an inch of snow. So take everything I say also with a grain of salt. These are just, stacking up odds. You can't forecast everything off of the historical record, but it's really cool to see how these stats kind of stack up. So you'll also notice too that La Nina doesn't always produce heavy snowfall in Portland. Since about 1999 until about 2016, that was a 15, 16 year period where we saw well below normal snow. The normal amount of snow right now is about 4.5 inches in Portland, and we saw 0 to 3 inches. So it seems like the odds, at least over the last 2 decades, have shown that La Nina winters don't really provide as much snow as we would expect, at least in Portland. Like something is changing. We're just a little too warm. We're not really seeing much snow. I also mapped out what I called analog years. This was a specific set of years that were La Nina years that I thought were very similar to our current ocean temperatures. There's an index called the ONI, the ONI, and that is just an ocean temperature anomaly. A bit complex, but the dotted line is the current track we're on, and my analog years are all of the colors there. And those were their observations as we headed into the next 3-month periods. So right now we are in the July, August, September period. Next is August, September, October period. Once the month finishes, they'll put out that next ONI index value. Anyways, the trajectory of the current ONI index is very similar to those 5 years that I chose to specifically look at. So it's kind of showing that possibly we'll see similar weather patterns to those years. And it's also important to note that the ocean really does have an influence on our weather. The big body of water, whether it's cold or warmer than normal can really influence our weather here. So this is why it's a pretty standard method of analyzing our winters to come. So when you take my analog years, those 5 years on average per month, this is the snow we saw. So the dark blue are those analog years. I also stack them up against the 20 or so La Nina winters since about 1950. And then you just have your normal snow totals per month through winter. So on average, we see about 0.2 inches of snow in November, on average about 1.5 in December, 1.4 in January, and so on. So my analog years actually showed quite a lot of snow come December and January. So odds are, stacking up if my years are right, and we do see a similar pattern. Potentially we see an active December and January. And also in general, you can see that just having it be a La Nina winter, the odds are in favor for above normal snowfall in the light blue. So that was interesting to see, but I also wanted to share how seasonal snowfall in Portland by decade has almost decreased by half over the last 4 decades. So back in the 1940s, if you divide those numbers by 10, you'll see the yearly seasonal average. So in the 1940s, we tended to get about 9 inches of snow per season. And ever since the 50s, the 60s, it's continued to decrease. And we've kind of leveled out since the 1980s with about 4 inches of snow roughly per year. So, that could be due to climate change. That could be due to just how systems are being affected by these pools of cold and warm water in the Pacific. There's a lot that could be influencing why our snow is decreasing by decade over the last 80 or so years. So much less snow here in Portland. Just for fun, I did do a little wish cast. That this is not expected to happen. Maybe it does, but I figured just with the odds that I looked at, that November would stay a little too warm to see any snow. In December, we could see maybe a trace. I did see better odds come January and February that we do see measurable snow in Portland. We possibly get maybe 1 or 2 events that drop maybe 1 to 3 inches of snow. But I do think we'll see either a near or below normal snow season as we head our way into this winter time. So, a lot of kids aren't in school, so I'm curious how snow days will happen, if they'll still have to go to virtual class, or if they'll get the day off to build a snowman. But we didn't see much snow last year or even the year before. It's been 2 quiet winters. So it'd be nice to get a change here. And I think with La Nina, there's a chance we do see some extreme, snow event that maybe drops 2 to 4 inches of snow, sometime in January. Again, rainfall is expected to be more than normal. We are coming off of a major drought all throughout the year. Since January, we've seen below normal rain every month except for maybe 2 months. So 93% of the state is still at some level of drought, and about 40% is in an extreme drought, which has kind of impacted our agriculture around here and a lot of the wine industry as well. So average rain per year is about 36 inches. We're in a deficit now of about 8 inches. So I am expecting this La Nina winter to bring relief to our drought. And these are some water year averages. Again, my years, the analog years, those 5 years that I mapped show closer to about 39 inches of rain. So that's above normal. La Nina tends to give above normal rain as well, with 38 inches of rain. Cascade Snowpack also shows some promising stats too. The La Nina tends to historically have given above normal snowfall in the Cascades. So I would bet it's a good ski season. I did just have an interview with Mount Hood Meadows and their operations director, and they have a complete COVID protocol in place. So if you are skiers, I think the season will be good, but there will be like a reservation system that goes in place to limit crowds and to enforce social distancing. So these are just more snow totals at Mountain Meadows. I was able to get a bunch of their stats. And yeah, La Ninas tend to produce above normal snowfall up in the Cascades at 5,000 feet. So yeah, that's exciting. I'm a big skier too. So this is the end. This picture is from Smith Rock. If you're familiar with Monkey Face, I did a traverse across the diving board. That's the side that's not attached to the tower. It took some friends who were very skilled with rope systems to rappel down, climb the other side, set up this traverse. And it's one where you're scooting across and you're attached in, and then rappelled down from the monkey's mouth, which you can kind of see the formation of the monkey there. It was about a 200-foot rappel. So that was a very fun adventure a couple of Octobers ago. I think it was in 2017 that I did that. Yeah, and I'm excited for more climbing. Hopefully we see some dry weather through October and the starts of November before ski season arrives. So thanks for listening to my presentation. You can watch CBS 4:30 if you're up early enough.